Hello everyone, welcome to AI tutorials. If you are looking for machine learning, deep learning, NLP, computer vision and AI related videos, then this is the right place for you to subscribe. And don't forget to tap the bell icon so that you don't miss any new video uploads. Thank you. In previous video, we have already completed how to change the shape of an array and take the transpose of it. In this video, we'll be concentrating about how to add or remove elements, and these can be done with the help of these four methods like resize, append, insert and delete. We'll see one by one. Before learning about the resize, we must know little bit about the reshape. So in the reshape, we can able to create the new shape of an array without changing its data. We have seen several examples. So here for the range of 9 numbers, we have created 3 cross 3 matrix using reshape. You can see it here. One drawback about the reshape is, in case if you want to create a new array where the size is not matching, in this condition this is 4, and if you try 3 cross 4 it is 12 elements, but we have created an array for 9 elements. It means both the size are different. If that is a thing, then we will get the value error. So this is the drawback of using the reshape method, and this drawback will be answered by the resize method. In the resize method also, we can able to create the new array with the specified size. Here we have two arguments, one is an array, then what is the shape we want to achieve it. So let's see with a practical example for better clarity. The first step, as usual, import NumPy as NP. So this time I am going to create an array for 12 elements. So when I execute, it created a one-dimensional array, contains 12 elements starting from 0 till 11. So we'll see three scenarios. The first scenario, we are going to create an array which is equal to the original size. So we are going to resize the array as 3 cross 4 shape, that is b variable equal to np dot resize. The first argument is an array. We have already saved into a variable a. Then what is the shape we want to achieve it? 3 cross 4, that is what mentioned as 3 comma 4. So when we print and see, initially it's a one dimensional array, contains 12 elements. Now this has been changed to two dimensional. It is 3 rows 4 column. 3 rows 4 column. Now also the elements is 12. It means new array size equal to the original array size. So of course we can do the same thing using reshape function also. Now we'll try to create a new array which is less than the original size, that is less than number 12. So let's try for 3 cross 3. It means 9 elements. Of course it is less than the original size 12. New variable c equal to np dot resize array a. We are trying for 3 comma 3, then printing the array. See here, it didn't throw any error. What happened here is, this 12 elements, based on the new size, it selected 3 rows 3 columns, and the shape is 3 cross 3, 9 elements, and the allocation of elements is from 0 to 8. It means it sequentially utilized the first 9 numbers because we demanded for 3 cross 3 matrix. So instead of throwing the error, based on your requirement, it will resize the array. Now We will see third scenario where the new array size is greater than the original size. It means it is greater than 12. We have only 12 elements, but what if we mention more than 12? Well, let's try to create an array for 4 cross 4 means it is 16 elements, which is greater than the original array. New variable d equal to np dot resize the array a comma 4 comma 4, printing the array, and you can see here it created 4 rows 4 column. Very important thing to remember here is it started from 0 till 11. It utilized properly nothing but first 12 numbers. After that it started repeating the same array in the sequential way. That is, once 12 elements is over, once again it will start from 0, 1, 2, 3. So instead of throwing the error, it will resize the array based on the shape. So that is a big advantage of using the resize, but using reshape, we'll be getting the value error. Hope you got a clear idea. So first example, so when you mention the exact size of an array, it will use properly. In case if you mention the size less than the total array size, then it will utilize till the limit it wanted. And if you mention the array greater than the original size, then it will repeat the same number in the sequential order from the index 0. So that's about the resize. The next method is append method. Using append we can add the element, but here this function append or add at the end of the input array. And here very important thing, while appending, that is while adding, we have to be very careful with the dimension in order to avoid the value error. Then in addition to that, we have a new parameter called access, that is whether to add it in the row wise or column wise also we can decide it. So this append method contains 3 arguments: array, what is the value to append, and in which access, that is row wise or column wise. We'll see with the practical example. First we will create the 2-dimensional array. Let me execute. So this is nothing but 2 cross 3, 2 rows 3 column. First example, we are trying to append without mentioning the access parameter. That is, in case if we are not mentioning this parameter, then what it will happen is it will create the 1-dimensional array by appending the values at the end. So we have to be very careful, if not it will create 1-dimensional array. So np dot append, so we have to append to the array A. I'm going to append 3 values and it's a 2-dimension. So within the list, another list that consider as a 2D. So 10 comma 10 comma 10. So when I execute, since we didn't mention the access, what happened is it just appended at the end of the array and it converted 2D into the 1-dimensional array. So mentioning access is very important. This is the existing array. Now I am going to append the elements by mentioning the access, and the access is equal to 0. It means it will be appended in the row wise, that is here. Same code, I am just adding one more parameter, access equal to 0. Let's execute and see the difference. This particular 3 value appended in the third row, that is row wise. So when you mention access is equal to 0, it will append in the row wise. Next example, we want to append in the column wise. For that, we have to mention access is equal to 1. As I already said, we have to be very careful while mentioning the shape, and the shape here is 2 row 3 columns. So when you want to mention here, it is also must be of 2 rows and a column as you wish. So np dot append to this array. I am appending like this, comma, access equal to 1, and you can see here this particular value appended here. That's why we got output like this. And if you don't want, you can remove one more 10 and one more 20 from both the size, then also it will work, but make sure it should be of 2 rows, then only this particular shape it will work in the column wise. So the points to remember, if you are not mentioning the axis, you will get the one dimensional array. Then to append the row wise, mention axis is equal to 0. Then to append the array in the column wise, mention axis is equal to 1. In both the cases, we have to be very careful with the shape. Hope you got a clear picture about these two topics. If you really think this content is worth, then don't forget to like this video. That's the end of this video. Thanks for watching. Happy learning.